Imagine floating in the depths of space surrounded by vast clouds of gas and dust. It's colder than any winter you've ever known, darker than any night you've ever seen, but amidst this seeming emptiness, something incredible is happening. A planet is being born. This rare cosmic event, which takes millions of years to unfold, is a fundamental part of the universe's cycle of creation. But what would it actually look like if you could witness it firsthand? Let's embark on a journey through time and space to explore the birth of a planet. Our journey begins in the vast cold expanse of space where stars are born. Not in the bright shining stars themselves, but in the swirling clouds of gas and dust that surround them. These clouds, called nebulae, are the nurseries of stars and planets. Imagine a nebula so vast it would take light itself thousands of years to cross it. Within these clouds, gravity is constantly at work, pulling together particles of dust and gas. Over eons, these particles clump together, drawn together like dancers in a cosmic waltz. As more and more material is pulled in, the cloud begins to spin faster and faster, forming a swirling disk of matter. At the heart of this disk, a young star ignites, blazing with the fires of nuclear fusion. This newborn star illuminates the surrounding disk, creating a breathtaking spectacle of light and color. Astronomers have spotted these stellar nurseries, these protoplanetary disks, in star-forming regions like the Orion Nebula and the Taurus Molecular Cloud. These disks, teeming with the raw materials of planets, are where our story truly begins. Now let's journey closer to this newborn star, into the heart of the protoplanetary disk. This is where the story of planet formation truly begins, a tale written in the language of dust and gas. Here, the real magic of planet formation begins. It's a process that spans millions of years, yet it all starts with the tiniest of particles. Imagine yourself surrounded by a swirling maelstrom of dust and gas, illuminated by the soft glow of the young star. This is the birthplace of planets, a chaotic yet beautiful environment where the seeds of worlds are sown. It's a chaotic dance of particles, each one on a collision course with destiny. Every collision, every interaction, is a step towards the creation of something much larger. At first glance, it might seem like chaos, but there's an elegant order to this cosmic ballet. The particles move in a delicate balance, guided by the forces of nature. Tiny grains of dust, barely visible to the naked eye, collide and stick together. These grains are the building blocks of planets, the first step in a long journey. This isn't gravity at work, not yet, but electrostatic forces, the same forces that make your hair stand on end when you rub a balloon on it. These forces are crucial in the early stages of planet formation. These tiny particles, drawn together by these invisible forces, begin to clump together, forming larger and larger aggregates. It's a slow process, but with time, these clumps grow. Over thousands of years, these aggregates grow from microscopic dust grains to pebbles, then to boulders. Each stage of growth brings them closer to becoming planets, and eventually to mountain-sized objects. These massive bodies are the precursors to planets, the building blocks of the solar system. It's like watching a time-lapse video of a snowball rolling down a hill, growing larger and larger with every passing moment. The process is slow but relentless, driven by the fundamental forces of nature. And just like that snowball, these growing clumps of matter are just beginning their journey. From dust to pebbles and eventually to planets, the story of cosmic creation is one of patience and persistence. Chapter 3. The Collision Chaos, Planetesimals Take Shape. Now, the real chaos begins. The serene and tranquil disk of dust and gas that once floated peacefully in the cosmos is now a battleground. Our once placid disk of dust and gas is now a shooting gallery of rocks and boulders, each one vying for dominance. These collisions are not just random, they are the very essence of planet formation. These massive objects, some larger than Mount Everest, are called planetesimals, and they're the building blocks of planets. They range in size from small boulders to objects hundreds of kilometers across. Imagine a cosmic game of billiards, but instead of balls on a green felt table, it's gigantic rocks hurtling through space at breakneck speeds. Each collision alters the course of these planetesimals, sending them on new trajectories. Collisions are inevitable and the results are spectacular. The energy released during these impacts can be immense, reshaping the planetesimals involved. When two planetesimals collide, the energy released is staggering. The force of the impact can be equivalent to millions of atomic bombs detonating simultaneously. Imagine the impact of millions of atomic bombs detonating simultaneously. The sheer power of these collisions can break apart planetesimals into countless smaller fragments. Some collisions shatter these planetesimals into countless smaller pieces, scattering debris across the protoplanetary disk. This debris can then collide with other planetesimals, continuing the cycle of destruction and creation. But other collisions have the opposite effect. Instead of breaking apart, some planetesimals stick together, merging to form larger bodies. Instead of shattering, the planetesimals merge, their gravity pulling them together in a fiery embrace. These mergers are crucial for the growth of planetesimals. These collisions, violent as they are essential to the planet-building process. Each impact not only reshapes the planetesimals but also contributes to their growth. With each impact, the larger planetesimals grow, their gravitational pull increasing, attracting even more material. This gravitational pull is what allows them to gather more dust and rocks, further increasing their size. Over millions of years, a select few of these planetesimals will emerge victorious, clearing their orbital paths and becoming the seeds of planets. These seed planets will continue to grow, eventually forming the planets we know today. Chapter 4. The Final Phase. A newborn planet emerges. Fast forward millions of years and the protoplanetary disk, once a chaotic storm of dust and rock, has transformed. What was once a swirling mass of cosmic debris has now begun to coalesce into more defined structures. The gravitational forces at play have caused the dust and gas to clump together, forming larger and larger bodies. These early formations are the building blocks of planets, the seeds from which entire worlds will grow. The few surviving planetesimals, now true giants, have swept their orbits clean, becoming the dominant gravitational forces in their region of space. These massive bodies exert a powerful influence on their surroundings, pulling in smaller objects and growing even larger. They are the architects of their own domains, shaping the young solar system through their immense gravitational pull. These are the newborn planets, still hot and glowing from the energy of their formation. Their surfaces are a tumultuous landscape of molten rock and searing heat, a far cry from the stable, life-supporting worlds they may one day become. The energy released during their formation keeps them in a state of constant flux, their surfaces ever-changing and volatile. Imagine a world still in its infancy, its surface a molten sea of lava crisscrossed by rivers of fire. The heat is unimaginable, the landscape a hellish vision of constant eruption and flow. This is a planet in its most primal state, a world where the very ground beneath your feet is in a state of perpetual motion. Volcanoes erupt with unimaginable force, spewing lava and gases into the nascent atmosphere. These eruptions are not just a spectacle of raw power, they are also a crucial part of the planet's development. The gases released during these eruptions will go on to form the planet's first atmosphere, a thick, toxic shroud that will play a vital role in the planet's future evolution. This is a world still being shaped by the forces of creation, a world very different from the one we know today. The surface is a chaotic mix of fire and rock, constantly being reshaped by volcanic activity and the relentless pull of gravity. It's a landscape in flux, a world where the only constant is change. But even in this alien landscape, the seeds of familiarity are being sown. As the planet begins to cool, its molten surface starts to solidify, forming the first crust. This is the beginning of a process that will eventually lead to the formation of continents, oceans, and the complex landscapes we see on Earth today. As the planet cools, its molten surface solidifies, forming the first continents. These early landmasses are the precursors to the continents we know today, the first solid ground in a world that has been dominated by fire and molten rock. It's a slow process, but one that will eventually lead to the diverse and complex landscapes that make up our planet. Gases released from volcanic eruptions form the first atmosphere, a toxic shroud that would be deadly to humans. This early atmosphere is thick with carbon dioxide, sulfur dioxide, and other gases, creating a harsh and inhospitable environment. But it's also a crucial step in the planet's development, laying the groundwork for the more complex atmosphere that will eventually support life. But this is just the first step. The planet is still young, and its journey is far from over. Over the coming eons, it will undergo countless changes, each one bringing it closer to the world we know today. The surface will be sculpted by volcanic activity, impacts from space, and the slow, inexorable march of time. Over billions of years, this newborn planet will continue to evolve, its surface sculpted by volcanoes, impacts, and the slow, inexorable march of time. Each event, each change, will bring it one step closer to becoming a world capable of supporting life, a world that will one day be home to countless forms of life, including us. Chapter 5. What if life emerged? The next chapter. Now imagine something truly extraordinary happening on this young planet. As it cools, water vapor released from volcanic eruptions condenses in the atmosphere, forming the first clouds. Rain falls upon the barren landscape, pooling in the lowlands, creating the first oceans. This is a pivotal moment. Water, the lifeblood of our planet, has arrived. In these primordial oceans, the building blocks of life, organic molecules, begin to assemble. It's a slow, painstaking process, driven by chance and the laws of chemistry. Over eons, these organic molecules form increasingly complex structures, eventually leading to the first single-celled organisms. Life has taken hold. Now imagine fast-forwarding billions of years. The once toxic atmosphere has been transformed by photosynthetic life, filling the air with oxygen. The once barren landscape is now teeming with diverse ecosystems, from lush rainforests to arid deserts. This is the power of planet formation, the power of the universe to create not just worlds but life itself. Outro: a universe of stories. Witnessing the birth of a planet would be like watching the ultimate cosmic fireworks show, stretching across millions of years. From a swirling disk of dust to a fully formed world, it's a chaotic, violent, yet beautiful process. While we can't yet travel to these distant worlds, telescopes like James Webb and ALMA are helping us see this process in action, bringing us closer to understanding how our own Earth was born. Every planet has a story, and if we could watch from the beginning, we'd see the breathtaking power of the universe creating something new.